Hi. Okay, so I'm basically recording this lecture. This is mainly for my juniors in period 2. Yeah, because I had you guys take the HSA test. Thank you again for taking that HSA test earlier, if you did, but okay. Well, anyway, this is the lesson that you missed. Okay, so this lesson was on section 9.3, which is properties of rectangles, rhombuses, and squares. Okay, so for this here, let's start with the first one. So rectangle, you guys have probably been familiar with rectangles before, so not really going to go too much in depth to that, but basically a rectangle is parallelogram. So here's the handout from last time. So these are all the qualities of a parallelogram, so it also applies to a rectangle. But instead now we have 4 right angles and the diagonals are congruent, so that the diagonals so this line would be congruent to that line. Okay, so the first part says find the missing measures of the rectangle. So this is pretty straightforward. If PS is 10, that means QR has to be 10. The sides that are opposite of each other are congruent. SR is 24. Doesn't get any easier than that. Okay, this is where it started to get a little bit tricky though. You want to find the measure of RPS. Okay, so what we know here is the measure of the measure of RPQ. If I had to draw it out like that, the measure of RPQ is 27. If we know that a rectangle has 4 right angles, one of the right angles is right here. If we want to find the measure of RPS, which is RPS, so we're finding this one here, this is just 90 minus 27, which is 63. And the way I got that was because we know that a right angle is 90 degrees. So 90 minus 27 is 63. So the measure of RPS is 63 degrees. Okay, QS. This was the fun one. Alright, so what I'm going to do is I'm going to redraw this shape. So I'll draw it right here. So this is a right angle. This is 24. This is 10. And this is length QS. So our goal is to find QS. So this is interesting because we have a right triangle. Let's see, I'm not sure if you guys remember this, but every time you're dealing with a right triangle and you want to find the missing side length, what you have to do is apply the Pythagorean theorem. So the Pythagorean theorem says the sum of the two short legs, the sum of the squares of the two short legs is going to equal the square of the bigger one. So if this is A and this is B, those are my two shorter legs. If you square both of them and add them up, it should equal the longer side squared, or the longest side. Yeah. So what you would do now is, so this is 10 squared plus 24 squared equals C squared. So C in this case is equal to QS. Okay, so this is 100 plus 576 equals C squared. Add these up, 676 equals C squared. If I want to solve for C, just take the square root. So let me show you how to do it on this awesome calculator. So you would press second, and then you look for the little square root symbol right there, and then 676. Press the right arrow, exit out. So that means our hypotenuse C is 26. Okay, so if C is 26, that means the length of QS is 26. Okay, the other part, so this part TR, so we know that QS is 26. So that also implies that PR is 26, right? So I mean, because the diagonals are going to be congruent, so this has to be 26. If we know that the diagonals bisect each other, so this is the parallelogram, diagonals bisect each other, basically this segment has to be the same as this one. PT is congruent to TR. So just like last time, if we know that QS is 26, we could also put PR. Why not? PR is 26. So TR is going to be half of 26. So this is just 26 divided by 2, which is 13. So yeah, this right here is 26 divided by 2. Yep. So that's that one. Okay. Now rhombus. Okay. So the rhombus is also a parallelogram. Has 4 congruent sides, so those are my congruent sides. Diagonals are perpendicular. So I don't know if you guys remember what perpendicular meant. So perpendicular, if I draw the diagonals, So those are my diagonals. In order for things to be perpendicular, what this implies is that each of these is a right angle. I can make it look all nice and fancy and stuff, but yeah, basically all of these angles are right angles. Okay, and then this part here says diagonals bisect opposite angles. So basically what that means is that this angle here is the same as this angle is same as this angle, etc. We'll get into that later though. Main thing is this one. Okay, so here it says find the missing measures of the rhombus. A rhombus has 4 congruent sides. Because they are all congruent to each other, KL has to be 13. Okay, the measure of J and K. So if I were to turn this around like this, so what this means, I'm guessing this is not to scale, I apologize, but basically if you have a rhombus and all of these sides are the same, what that means is that this has to be a right angle because these diagonals have to be perpendicular to each other. So that means the measure of J and K is a right angle, and we know that a right angle measures 90 degrees. Okay, the measure of JMK. So JMK actually comes from the diagonals that bisect opposite angles. So for example, what we said was this angle is going to be congruent to this one because it's bisected. So if this is 40, this one also has to be 40 because the diagonals bisect opposite angles. So the measure of JMK is going to be the same as this angle here. So that is 40 degrees. Okay. This one I put 2 stars here. This was a fun one. Okay, so this one took a little bit more thinking. So in order to solve for NK, now what you have to do is it might help to draw this triangle separately. So if you draw it separately, what we know is that we have a right triangle here. This is 5, and this is 13. This is J, this is N, and this is K. So what this means is that every time you are faced with a right triangle, what you want to do is, if you want to find the unknown side length, you have to apply the Pythagorean theorem. Okay, so what that implies is, what we know that is that this is going to be the longest side. So this is our hypotenuse. Our hypotenuse is C. We have to find one of the legs. We know one of the shorter legs is A, and the other shorter leg would be B. So apply the Pythagorean theorem. A squared plus B squared equals C squared. A is 5, 5 squared plus B squared equals C squared. C squared is 13. C is 13. Okay, so here 5 squared is 25 plus B squared equals 13 squared is 169. If I subtract it through, B squared equals 169 minus 25 is 144. Then I can take the square root, so B is 12. Okay, so that implies that B, or the length of NK in this case, is 12. So this is 12. Okay, so MK. MK is the interesting one. So this goes back to the example we had over here. So what we know is that the diagonals are going to be bisected. So if nk is 12, that means mn has to be 12. Since mn is 12 and nk is 12, in order to solve for the whole length from m to k, this is 12 plus 12. So this is 24. This is 12 plus 12. Okay. JL, so in this case, if this is 5, NL has to be 5. So this one is 5 plus 5, which is 10. Yep. So that's pretty much it for this handout, if you're wondering. Okay, so this was rectangles and rhombuses. Okay, next part. The square. Alright, so a square has 4 congruent sides and 4 right angles this time. It has all the properties of the things that we discussed earlier. It has all the properties of a parallelogram. It has all the properties of a rectangle and a rhombus. So, yeah, it's pretty crazy. But anyway, we'll go into that in depth soon. Okay, so find the missing measures of the square. Round your answers to the nearest 10th. Okay, so what we know about a square is 4 congruent sides and 4 right angles. That means all of these sides are congruent. That means AB has to be 11. Okay, next part. So DB, that's the fun one. Okay, so what we know is that a square has 4 right angles, but the one I'm just going to mainly look at is the one there. So if I were to draw this on the side, so this is 11, and this is 11, and this is a right angle. Now if you had to look at this, if you looked at this diagram, what we see is that these 2 legs are the shorter sides of a right triangle now. And this hypotenuse is now the longest side of the right triangle. So if we had to apply the Pythagorean theorem, we know that A is 11 here, B is 11. This is our hypotenuse. Hypotenuse is C. So apply it. So A squared plus B squared equals C squared. This is A, this is D, and this is B. Okay. So if you had to solve it through, 11 squared plus 11 squared equals C squared. This is 121 plus 121 equals C squared. 242 equals C squared. So once you get that, find the square root of 242. So this is our magic calculator. So we go second, and we use this here, 242. So it says it's about 15.55. I'm going to round that to 15.6. So C is approximately 15.6. So that's the length of DB. So this is 15.6. DE. Okay. So if we know that this whole length is 15.6, what we know is that from earlier, we know that since a square is also a parallelogram, what we know is the diagonals bisect each other. So that means if DB is 15.6, that means DE can be solved by just going 15.6 divided by 2. So that means this segment is the same as that one. So if I do that, 15.6 divided by 2, 7.8. Okay, so that means DE is 7.8. Okay, measure of angle ADC. ADC, well, that's a right angle. This is 90. That one was pretty easy. AEB. So if we want to find the measure of angle AEB now, this one refers back to the rhombus. So a square has the properties of a parallelogram, a rectangle, and a rhombus. And what we know here is that a rhombus, for a rhombus, the diagonals are perpendicular. So what this implies is that if the diagonals are perpendicular, that means this angle has to be a right angle. So that means the measure of angle AEB also has to be 90 degrees. And the last one, the measure of angle ADB. So what we also know about a rhombus is that diagonals bisect each other. bisect opposite angles. So if they bisect opposite angles, that means it's splitting the 90-degree angle into two equal parts. So this right here is going to be 90 divided by 2. So that means so this angle ADB and BDC and all those, they're all going to be 45 degrees. Okay. Yeah, that was a lot of information. Okay, so not quite done yet. We are almost done. So next part. Okay, so next part I did was a few examples. Okay, so this part here says ABCD is a rhombus and find each measure. So I purposely went over this in class because the book had some kind of ugly numbers, but we'll deal with it. So find AB. So what we know about a rhombus is that all the sides are going to be equal or congruent. So what this implies is, so this is, we can do BC is equal to or is congruent to CD. So what this implies is BC equals CD, and 4x plus 15 equals 7x plus 2. So if I went and solved this out, I can subtract 4x on both sides. You know what? Since I'm going to do number 10, I'm just going to cross this out. Actually show all the work. Okay. So subtract 4x. So what this implies is 15 equals 3x plus 2. Then I can subtract 2 on both sides. 13 equals 3x. Divide by 3 to solve for x. So that means x, let's see, 13 divided by 3 is 4.33. So I'm just going to put 2 decimals. I rounded 2 decimal places. This is 4.33. So that's how you solve for x. So now what you can do is you can plug it into BC, you can plug it into CD, it doesn't matter. Basically, the sides of a rhombus are all the same. So we could just try it. So BC equals 4x plus 15. So this is 4 times 4.33 plus 15. So if we did math, so 4 times 4.33 plus 15, and that's about 32.3. If I had this up here, this is actually 32.33. Yeah. Okay. Similarly, if you wanted to, you could solve for CD. So I guess this is a check, I guess. Okay. So CD equals 7x plus 2. So 7 times 4.33 plus 2. And if you do that out, that should also work. 7 times 4.333 plus 2. Yep. So this is 32.33. So what we know is that BC must equal CD. But our goal was to find AB. So if we want to just find AB, this one was basically, we know that AB equals BC, which equals CD, which equals AD. The only one we needed was AB. If we know that BC is 32.33 and CD is 32.33, that means AB has to be 32.33. Okay, and I have one more problem. Okay, so number 11. Find the measure of each angle in the rhombus. Okay, so let's bring this back here. So we have a rhombus. A rhombus has diagonals that bisect opposite angles. Since they bisect opposite angles, that means this angle here has to be 27 degrees. Measure angle 5 is 27 degrees. Okay. Another thing that we know is that, oh, what happened? Okay. So another thing we also know is that because you could say that because this is parallel and this is parallel, so we know that a rhombus is a parallelogram. Rhombus is a parallelogram. So what this implies is that angle 2, this angle and this angle are alternate interior angles. So this means measure of angle 3 has to also equal 27. And by default, if this is 27, this is 27, and this is 27, so we know that opposite angles are going to be congruent. So this whole angle and this whole angle here. So what this implies is that measure of angle 2 also has to be 27 degrees. Now, this is where the fun begins. So let's say if we know measure of angle 5 is 27 degrees. And we know that this is also 27. And this is 27. So if I were to redraw this, let's say I wanted to solve for, so I still need to solve for angle 1 and angle 4. So what we know is 27 plus 27, this here is going to be 54 degrees. 27 plus 27 is 54. What we also know is 27 plus 27 is 54 degrees on this side. If we know that a rhombus is indeed a parallelogram, and a parallelogram says that you have two pairs of parallel sides, we know these are parallel. We also know that these are parallel. Okay, so what this implies is that if you have two parallel lines, same side interior angles are supplementary. So same side interior angles, this angle plus this angle has to equal 180. So this angle here is just 180 minus 54, which is 116. And that means if opposite angles are congruent, this is also 116. So what this implies is measure of angle 1 must also equal the measure of angle 126. 126. Holy cow, I made that same mistake in my period 2 class. Okay, 180 minus 54 is 126. And this one is also 126. So the measure of angle 1 it must equal the measure of angle 4, which is this one here, this one here, this one here, this one here. So that means that is 126 degrees. Okay. Woo, that was a lot. Okay, that should be enough to help you answer the questions on your homework. Let me know if you have any questions. Thanks.